all of the exercises that you've been assigned so far have to do with areas, and volumes as well, because that's kind of like the main application of integration, right? So I want to give you an example of an area. When you have them with log functions, because of the work that we've just done, you now have two methods that you can use to evaluate these. Okay. So for instance, draw yourself up a little sketch of log x, and we'll do a really simple area. Okay. All right. What's the intercept for starters?
1.
Just 1. Okay. So let's do, like I said, a nice simple area. Let's go up to E. So if that's 2, then 2.7 is something like that. Okay. Now this is log x. By the way, why did I choose E? Why is it actually going to give us something simple?
Because it's just 1.
Okay, so when I'm evaluating the integral, or whatever it is, the e and the log x, they're going to mix together and it's going to be super simple for us. Okay, stuff is going to cancel out and we'll have nice numbers. Okay, I suppose I could have had like e squared or e cubed. All of those will give us nice values for the y-axis, as you'll see in a second. Okay, so if I want to work out this area, okay, I've got two alternatives. I can use this fancy thing that I've just created. Okay, so a very common thing might be, okay, here's your question. You know, this is question 14 or something like that. Here's part A, differentiate that. Part B will be, hence, write a statement for the integral of this. And then part C will be, okay, give me an area. Okay, and as you guys know, I hope, when you've got a part A, B, C type question, right? If they all say, show this, show that, hence, even if you can't show these things, if they are written down in the exam and you're like, I tried it and it just broke down, okay? But there's 2 marks over here, and I know how to use this stuff to get there, you can just assume it. You start at part C and have nothing written for A or B and say, blah, blah, blah is true from part A. And then you just start working. Okay, so even if you can't prove it, you can still use it. We already have proven it. So how would we use it here? Okay, well, you just form the integral. It's nice and easy. What are the upper and lower bounds? 1 to E. Get in the habit of saying the lower one first, because it's the direction of an integral, a definite integral actually does matter. Yeah. This is the function we're integrating with respect to x. Okay. Now we know what the primitive is because we just worked it out. Because it's definite, we don't need to worry about the constant. Okay. So let's just go ahead and evaluate. You do the upper bound first. So I'm going to get E times log E. You see what I mean? Okay. Minus E. Then you subtract the lower bound. So what are we going to get? 1 times log 1 minus 1. Okay. What's log E?
1.
It's 1. So this is actually E minus E. Minus, what's log 1?
0.
That's 0. So this is 0 minus 1. So this disappears. That doesn't matter. Double negative, you get 1. You're like, what? All that work just for 1. Okay. So there's your actual, sorry, singular. There's your area. Okay.